Now I am going to teach you Engineering Mathematics first. According to Anna University Syllabus, Unit-1, Matrices. Now I am going to teach you what is matrix. Matrix means nothing. It is only the arrangement of row and column. This. When we write anything like this manner, then it is called as row map. When we write anything like this, it is called as column map. And when we arrange this row and this column in rectangularly, then it is called as the arrangement of matrix. See very carefully. We can represent matrix from A matrix. The symbol of A matrix is like this. See. Okay. This is one rectangular shape. Now we arrange the elements. When we write A11 means elements which is present or which is situated in first row and first column. Now see, A12 means this element is situated in first row and second column. Now A13, this element is situated in first row and third column. Like this, A1 and means nth means infinity. This is the first row element which is situated in nth column. First row. Okay. Now A21 means a matrix. Here this element which is situated here at second row and first column. Like this, A22, A23 and A2n. This is called as second row. Okay. Now see. Like that, infinity. Normally we can represent infinity at the end. Means according to that, this is A and N means nth row and nth column. Nth row and nth column. But in matrix, we cannot do like that. In matrix, row is represented as M and the column which is represented by N. Then we can write here A, M, N. This is M row and N column. N1, A, M, N2, A, M, N3, like that, A, M, N. Okay? Matrix, the arrangement of matrix should be like this. This is nth row. See, first column, second column, third column and nth column. So now we can easily see these things. We are what we are doing here? We are arranging the elements in row and columns. Means the arrangement of elements in row and columns is called as a matrix. Now you understood what I am going to say you? Matrix means nothing, it is nothing, only the arrangement of elements in row and column in a rectangular manner. Okay? Okay. Now I am going to tell you order of matrix. See. Order of matrix. See. Order of matrix. Okay? It is represented as M Cartesian N. M means what? Row. And N means column. And this is not multiplication sign. This only indicating how many row and how many columns in this matrix. For example, this 3 Cartesian 3 matrix. Means we can write it like this. A11, A12, A13, A21, A22, A23, A31, A32, A33. This is 3 Cartesian matrix. Means this is called as order of matrix. Similarly, 2 Cartesian 2, 1 Cartesian 2, like that. Whatever they are giving, no, we can write, we can represent this like that. And this is not, this is a element. This is only elements. Okay? Let's see next topic. Types of matrix. Types of. It may be useful for class 12 students also. Though you are currently studying in class 12, it may be useful for those also. Because in class 12 also we have to study these things only. This is from class 12. Types of matrix. First types, row matrix. Means a matrix which has only one row. Like this. A11, 1, 2, 1, 3. Means a matrix only one row. This type of matrix is called as a row matrix. Next one. Column matrix. Means a matrix which has only one column. A11, A21, A31. This is row matrix, this is column matrix. Now I think you understood what is row matrix and what is column matrix. Row matrix means nothing, a matrix which has only one row, and column matrix means nothing, a matrix which has only one column. Okay? Now third one, a square matrix. C. A square matrix. I think everybody know about a square. How a square it looks like this. This is a square. No? This is a square only. No, this no. It's not look like a square. Okay. But just imagine this is a square. Means a square means nothing. All sides equal. This is a square, no? Like that here also. See. A square matrix means nothing. M is equal to N. When row and column both equal, then it called as a square matrix. Let's see. Example. A11, A12, A13, A21, A22, A23, A31, A32, A33. See here. Here, number of row. How many rows? See, 1, 2, and 3. Here, number of row is 3. Means M is equal to 3. How many columns? 1, 2, and 3. Here, how many columns? Means 3 columns. That is N equal to. Now see, M is equal to N. Hence, when number of rows and number of columns are equal, then it called as a square matrix. Now, diagonal matrix. Diagonal matrix. Diagonal matrix. Diagonal matrix is also a square matrix. See, let's see. This is, suppose this is a square. Okay, and this is called as leading diagonal. This is called as diagonal. Okay. So what is diagonal matrix? A matrix where the elements are present only diagonally and other all elements are 0. For example, this 1, 0, 0, 0, 2, 0, 0, 0, 3. Here we can see the elements are present only in diagonally, other all elements are 0. It is called as diagonal matrix. A scalar matrix. A scalar matrix. A scalar matrix is also a diagonal matrix. But what is the difference between diagonal matrix and a scalar matrix? In a scalar matrix, the elements which is present diagonally is same. For example, 2, 0, 0, 0, 2, 0, 0, 0 and 2. Okay? This is diagonal, no? Here all the diagonal elements are equal. It is called as a scalar matrix. Null or zero matrix. It is another one type of matrix. Null means what? Nothing. Zero means a matrix which has nothing, that is called as null matrix or zero matrix. This is null matrix or zero matrix. Another one type, unit or identity matrix. Unit or identity. Unit means 1. Means a matrix where the diagonal elements are 1. That is called as unit matrix. It is also a diagonal matrix as well as a scalar matrix, but a matrix which has only one diagonally is called as unit matrix or I think you understood these things. Unit matrix means nothing, a matrix which has only one diagonal. Unit means 1. Here we can see 1, 1, 1. This is called as unit matrix. Now another one type. That is upper triangular matrix. Upper triangular matrix. I think you all know what is triangular. Means triangle. Okay. Upper triangular matrix. How matrix looks like? Matrix looks like this. Okay. And upper triangle means the matrix where elements are present above the diagonal. We can see examples like 1, 2, 3, 0, 1, 2, 1, 0, 0. This is called as upper triangular matrix. We can write it like this also in symbolic form. U is equal to U11, U12, U13, 0, U2, 2, U23, 0, 0, and here U3. It is called as upper triangular matrix. Means the matrix which is forming like a triangular shape, no? See, we can see here. It looks like a triangle, no? See? Means matrix which is forming like a triangular shape, upper side. Similarly, we can see lower triangular matrix. Lower triangular matrix. In upper triangular matrix, what we see? We see the elements which is below the leading diagonal elements. Below 0. But in lower triangular matrix, the elements which is upper the leading diagonal elements, that will become 0. Suppose matrix A equal to, draw diagonal element 1, 2, and here 3. Okay. 0, 0, and 0. There are something 4, 5, 6. In lower triangular matrix, we can see matrix looks like a triangular. It looks like a triangle, no? Here, above the leading diagonal element, this is called as a leading diagonal. I already discussed below. Leading diagonal. And here, above the leading diagonal elements, all the elements are 0. This is called as a lower triangular matrix. In symbolic form, we can write it as a C. L is equal to here L11, 0, 0. L21, L22, 0. L31, L32, L3. So this is lower triangular matrix. Now you understand what is lower triangular matrix? In lower triangular matrix, the elements which present above the leading diagonal elements is 0. It's, we can say, it is just opposite of upper triangular matrix. It is just opposite of upper triangular matrix. Now, transpose of a matrix. Suppose, take one matrix, 3 Cartesian 3 matrix. Example, let matrix A is equal to 1, 2, 3, 4, 5, 6, 7, 8. In transpose, what we have to do? We have to interchange row into column and column into row. What we have to do? We have to interchange this. Row into column and column into row. Got? So just see here. A transpose. Take first row. This first row. We have to convert this first row into first column. Okay? First row is what? 1, 2, 3. And here first column 1, 2, 3. Next, this second row. This is second row. What we have to do? We have to convert this second row into second column. 4, 5, 6. Similarly, for third row also into third column. 7, 8, 9. Means in transpose of a matrix, what we are doing? We are converting this row into column and the column into row. This it is nothing. It is only the interchange of row and column. It's called as a transpose of a